This is 8.3 inverse trig functions. So far we've been doing functions that kind of look like this, where you have the sine of pi over 4. So I put in an angle, and what you get out is like a ratio, like square root of 2 over 2. But now what we want to do in the section is that, what about if instead I give you the square root of 2 over 2, can I possibly get the pi over 4 back? Okay, so that's kind of the interesting thing about inverse trig functions, that inverse trig functions are basically undoing what the trigonometric function is doing. So the way that we write inverse functions, so if you have a function f of x, if you remember from algebra, the inverse function is going to be f inverse. So this guy is f to the negative 1. We don't say f to the negative 1 power. We say f inverse. Okay, so be aware that this is not a power of negative 1. Okay, it's really confusing. I mean, mathematicians made it a little confusing when they wrote the negative 1, but that's basically what it means to be f inverse. Okay, one thing to kind of note is that when we're doing the inverse, since we're swapping the two variables, we're swapping the input and the outputs, it will make sense that the domain and the ranges are going to switch. Okay, so if you have the trig function, you know that the input values, all the domains, are going to be all the possible angles. And what you're going to output is going to be all the ratios. Okay, here with the inverse trig function, my domain now is going to be the ratio, so I'm going to put in the ratios, and what's going to come out is going to be all of the angles. So they're kind of swapped, and that kind of makes sense, right? Because if you're doing the opposite, you basically are swapping the x's and the y's. Okay, so if I want to have f of x, so if I write sine of x as the function f of x, so if you remember, f of x is just a fancy word for just y. Okay, a function is a function if it passes the vertical line test. So if you have a graph that kind of looks like this, I know that this guy is going to be a function if it passes the vertical line test. So the vertical line test says that it can only go through one particular point. Okay, so the sine function, clearly, okay, if I were to graph the sine function, that looks like this. Okay, and it continues on. You know that this is only going to go through the graph only once. So each vertical line is going to go through it only once. Okay, so that's just about f of x, just in case you forgot. Why are we writing f of x instead of y? F of x is just another way to write y. Okay, so if I know that this is the function, then the way that we write the inverse of a function is this way. F inverse of x equals sine inverse of x. Okay, so here I give you some examples. So if I input pi over 6 into sine, I go into the unit circle or your calculator, and you can see that that's 1/2. So the way that I write it the opposite is that pi over 6 is equal to sine inverse of 1/2. So notice here that I'm taking the sine inverse of this 1/2. Okay, cosine of pi equals negative 1. I can write pi equals cosine inverse of negative 1. Okay, tangent of pi over 4 equals 1. So that means that the pi over 4 is equal to the tangent inverse of 1. Okay, so this is just how kind of we write tan inverse, cosine inverse, and sine inverse, how we express them as inverse trig functions. So this chart is actually really important. You don't need to know the graphs themselves, so the inverse trig functions, but you do need to know the domains and the ranges. Okay, so do take really note of that. So this is kind of giving you a little summary of what we're going to be covering in this section. So we'll do a couple of examples also on what you're going to be seeing with inverse trig functions. So on a little side note, you will occasionally see the word arc sine, arc tangent, arc cosine. So see how I kind of have arc here, arc, and then arc. So arc is basically the same thing as sine inverse. So do make a note of that whenever you see arc sine of x, that's the same thing as taking sine inverse of x. It's the same exact thing. I'm going to be using them both, so make sure that you really understand whenever I say arc sine or arc cosine, you know exactly what I'm talking about. I'm talking about sine inverse. okay, or it's cosine inverse. So you can see that writing the word arc makes a little more sense because you're basically finding the arc that or finding if the arc is this, what is going to be the angle. So because if you remember a radian, if you think of the radian, and here's theta, right? How these are related, right? If you remember this, and if the radius equals 1, then the arc length is equal to the theta value, right? So you can kind of think of arc and theta as it, so I guess it kind of just makes sense. But just remember, arc sine is the same thing as sine inverse, okay? Just fancy word. Okay, so we're going to start off with the sine function first. So we know that a function, in order for something to be a function, it has to satisfy the vertical line test. So in order for something to have an inverse, it needs to be something called 1-to-1. And basically what it means is that if I were to graph something, there is only 1x and 1y for each pair, okay? So you cannot have multiple pairs. So for example, this guy is 1-to-1 because if you look at a random y, there's only going to be one particular x, okay? And one way that we know if something has an inverse or if something is 1-to-1 is that we use not the vertical line test. Vertical line test is for functions. We use something called the horizontal line test. So we use a horizontal line, kind of like this one, on the sine function, and we hope that this horizontal line will only cross the curve only once. But you can see that it's crossing it at many different points, which means this is not 1-to-1. In general, whoops, not one. I didn't write it right. So not 1-to-1. So in general, this is not 1-to-1, which means that there's no inverse. There's no inverse that exists by using this entire sine curve. So instead what we're doing, because we know that this is violating it, we are going to take a small piece of the graph. So we're going to take a small piece, maybe this guy, and you can see that this red curve now satisfies the horizontal line test because it's only going to touch the graph only once, okay? Because I'm ignoring everything else. Everything on the outside I'm ignoring. I'm only looking at the red graph. So if I say that this red graph is my new sine function, you can see here that my theta values, my domain, is going to be from negative pi over 2 to pi over 2. And here my range is going to be from negative 1 to 1. So nothing really has changed. I just restricted the domain and the range. Notice that I could have chosen any other point. I could have chosen this graph from here to here, from pi over 2 to 3 pi over 2. I could have chosen this part. But just for simplicity, we're just going to choose that guy. Okay? So I choose this guy. Okay? So this is going to be my new sine function. And now what I'm going to do, because I know that there's there's now a restriction in the domain, what I'm going to do is that I'm going to change them. Okay? So now this point right here, which is negative pi over 2, comma negative 1, what I'm going to do is I'm going to swap them. So now this guy is going to be negative 1, negative pi over 2. So this guy is going to go here. Okay, I just swap them. So I'm going to take every little point here and I'm going to just swap them. And the new curve that we end up getting is a graph of inverse sine. So now what you can see is that if you look at the regular sine function, my x values were negative pi over 2 to pi over 2. Now my y values are negative pi over 2 to pi over 2. For the sine function, my y values were negative 1-to-1. So now my x values are negative 1-to-1. So everything has been swapped. So this is now the graph of the inverse sine. Okay. So just, you don't really need to memorize this graph. Like I said, we're not going to be really shifting them and compressing them. I don't think that's something that we really want to do. I just want to make sure that I show you guys how to get an inverse. Now, be very careful because here, the domain of this inverse function is going to be from -1 to 1, and the range is going to be from -π/2 to π/2. Which means that if I put any value that I want into the inverse sine function that's between -1 and 1, what I'm going to get out is a number between -π/2 and π/2. So you have to be very careful because -π/2 is right here, π/2 is right here, which means that the inverse sine is only going to give you values in quadrant 1 and quadrant 4. Okay, so we have to be very, very careful about these restrictions. Okay, so even though we know that there's going to be multiple angles, remember we're only doing it based on this restriction. In terms of the calculator, you'll see that in the calculator you will see an inverse sine. So if you have the TI-36, you'll see sine and sine inverse. If you want to get the sine inverse, just press button twice. So if you have your calculator with you, press that button twice and you'll get the sine inverse of what you want. Okay, so let's do a couple of examples here. So find the following. So remember here that for sine functions, okay, the domain is -1 to 1, and the range is from -π/2 and π/2. Alrighty, so now what we want to be able to do here is figure out what sine inverse of 1 is going to be. So remember, what this is saying is give me the angle that will give me a sine of 1. Okay, so if you think of the unit circle and if you think of our restriction, in this particular restriction, where exactly do we have sine being 1? Well, sine is 1 up here. Here's where sine is. Okay, so sinus 1 is there. Sine inverse of sine, or you get the 1 here because you know that the sine is going to be the y value. So what angle corresponds with this particular point? Well, that's just π/2. Okay. A way that you can do it is you can put it in your calculator and you see π/2 as well. Okay. So now let's look at this guy. We have sine inverse. We want to figure out where exactly do we get positive square root of 2/2. So if you look at the unit circle, you see that you have here, at this particular angle, you have square root of 2/2 and square root of 2/2. This angle corresponds with π/4. That's going to be the answer. Now remember, there is another angle where this sine inverse, where this sine is square root of 2/2. And remember that, if you remember that you have all students take calculus, remember that sine is also positive here. So even though this guy is π/4 right here, and this one's associated with square root of 2/2, square root of 2/2, in quadrant 2, you have another one, another angle, where it's negative square root of 2/2, square root of 2/2. This is 3π/4. Okay, so notice that the y values, our signs are the same, but the answer is π/4 because we have to go based on the restrictions that they give us. This is my restriction. I'm only restricted to these values. Okay. All right. So now what about this one? So you want to find the sine inverse of -1/2. Okay. So you have to kind of think about where exactly sine inverse of -1/2 is going to be. So I can only get these values. Okay. So if you look at the unit circle, you have here square root of 3/2, comma -1/2. Okay, so what angle does that correspond with? Okay, now you would say that the angle that corresponded with would be 11π/6. Now that's not correct. It's not 11π/6 because remember the restriction is between -π/2 and π/2. So if this is 0 radians and right above it is π/6, then right below it is going to be -π/6. That's what that is going to be. Okay. Now here, what exactly is this? Well, let me show you a little trick on how to do this, because clearly 1/3 is not in the calculator, okay? Or it's not on the unit circle. So what are we going to do? Well, we have to use the calculator, but we're not going to do that instead. Instead, what we're going to do is we're going to think about what exactly is taking the sine of sine inverse do. Well, if I take the sine of sine inverse, all I'm going to be left with is 1/3. Okay? So basically, think about this guy as canceling each other out. It's kind of like if you're taking, like, if you have 3, and then I multiply it by 1/3. Okay? Those guys cancel each other out. So all I'm going to be left with here is going to be 1/3. That is going to be my solution. Okay? All right, now here you have to be even extra careful. The answer is not 3 pi over 4. You gotta remember the restriction. Okay, so here you really have to be very careful with this. Okay, so what is the sine of 3 pi over 4? Well, if you think about the sine of 3 pi over 4, 3 pi over 4 is over here. Okay, and this is just going to be square root of 2 over 2, square root of 2 over 2, where the first one is negative. So that means this guy right here is going to be square root of 2 over 2. Okay, that's the inside part. Now we have the sine inverse still on the outside. Okay? So what is going to be the sine inverse of square root of 2 over 2? Well, we just found that. That's over here. It's part B. So this answer is pi over 4. So you have to be very careful, because these can only cancel each other out if you're within the restriction. Notice here this 1/3 of sine inverse, well, that was within this domain, right? So you were completely fine. Here, you couldn't just cancel it out and get 3 pi over 4, because 3 pi over 4 is not in the domain, it's not in the range of sine inverse. Okay, so we have to be very, very careful with that. Okay? All right, here clearly this is not going to go away. You can't have cosine and sine inverse go away. Okay, so the first thing that you got to do is try to figure out what exactly is the sine inverse of 2/3. Okay, so one of the things that you can do is you can use your calculator. That is not quite what I want you to do. So something that we're going to do instead is we're going to make a substitution. So we're going to pretend that this guy is going to give me some angle theta. So what we're going to write is cosine. So we're going to do nothing with the cosine. And we're going to substitute this guy with theta. Okay? So here, this theta is equal to whatever we're plugging in here, which is basically sine inverse of 2/3. Okay, that's what theta is equal to, sine inverse of 2/3. Okay? Now what I'm going to do is I'm going to apply a sine to both sides. Okay, I'm going to apply sine to both sides. Because look what's going to happen. When I apply sine to both sides, you're going to have sine inverse of 2/3. Okay, remember that these signs here are going to go away. This guy's inside the domain, so it's good. Okay, so we're going to have sine theta is equal to 2/3. Okay, because imagine this is just canceling each other out. So you have sine of theta is equal to 2/3. So now all we got to do is figure out, how am I going to find the cosine of this? Well, if I know that the sine of theta equals 2/3, well, that's just a triangle. Okay, so I'm going to draw a triangle. Here's theta. It's a 90-degree triangle. Okay, I know that the sine is the opposite over the hypotenuse, so this is going to be opposite over hypotenuse. So what is going to be the adjacent side? Well, remember that's just going to be the Pythagorean theorem. A squared plus b squared equals c squared. Okay, so a squared in this case, I don't know what that is, plus 2 squared equals 3 squared. So you're going to have a squared plus 4 equals 9. A squared is going to be equal to 9 minus 4, which is going to give me 5. So a equals square root of 5. So this guy is going to be square root of 5. Okay? So now, notice that we created this triangle with 3 different sides. So we know that using this guy, we were able to create all of this. Remember, what were we trying to figure out? We were trying to figure out initially what this guy is. So what we did is we made a substitution with this inside part using theta. Okay? Now what we need to figure out is, okay, well, what is cosine of theta? Cosine of theta will give me what I want. So finding the cosine of theta of this guy will be the adjacent over the hypotenuse. That gives me square root of 5 over 3. And that would be the answer. Okay? So we're going to do a lot of problems like this in the next couple of videos. So even if you didn't quite get it, don't worry, it's going to come back. So we'll finish up this section with this last one, cosine of sine inverse of x, when x is positive. Okay? So let's start off by the same way that we were doing it before, cosine of sine inverse of x. So we're going to start off by letting this inside be something. So I'm going to say theta again. So I'm going to have cosine of theta. So this is basically solving this guy will be the same way as solving this guy. Now remember, what was theta? Theta was this middle part. Theta was equal to sine inverse of x. So now what we're going to do is we're going to apply a sine to both sides. Okay, this is going to go away. So I'm left with sine theta equals x. All right. So now I'm going to do the same thing that I did before. I'm going to draw a triangle. Okay. So remember, sine of theta is going to be the the opposite over the hypotenuse. You can always write this x as x over 1. So there can be an x over here. If this is theta, you have x over there and then an over 1. Okay, so what would be the other side? Well, remember, a squared plus b squared equals c squared. So a, we know that it's going to be just by itself because that's what we're solving for. B is going to be x squared. C is going to be 1 squared. So I'm going to subtract by x squared. You got a squared is equal to 1 minus x squared. Take the square root. Okay, so you're going to get a is equal to, okay, so is it positive or negative? Well, remember that we want x's to be positive. And if the x's are positive, that means that the sign is going to be in quadrant 1. So this guy should be positive. Okay, so now all we got to think about is, well, this guy is going to be square root of 1 minus x squared. Okay, so what's going to be the solution? Okay, well, we need to figure out what cosine of theta is. Cosine of theta will be the adjacent over the hypotenuse. So the answer will be square root of 1 minus x squared divided by 1. And of course, you can get rid of the 1. You can just write it as square root of 1 minus x squared. And that will be my solution.